Hey, today we're going to talk about some right triangles, specifically about one of the two special right triangles that we need to know, and that is a right triangle that has two 45-degree angles and, of course, one 90-degree angle. So add this to your flip book. The legs and the hypotenuse in a 45, 45, 90 special right triangle have a special relationship. So if we look at this right triangle, we can even get even more specific than calling it a right triangle. We can call it a isosceles right triangle because this angle is 45, this angle over here is also 45, so these two sides, or these two legs, are going to be the same length. So this is what we call a general right triangle, a general 45, 45, 90 right triangle. If each of these two legs is one unit, then the hypotenuse, the side across from 90, is root 2 units. So these two legs are the same. In this general right triangle, we call them 1, and the hypotenuse is root 2. That might be horribly confusing, so let's do an example because I think it might be a little bit clearer just by doing an example. So here I have a right triangle. I know that because of the red box that tells me this is 90 degrees. This angle is 45, and whenever one angle in a right triangle is 45, that makes the other angle 45 as well. So I'm going to use that general triangle that you just added to your flip book, and I'm going to draw that triangle in the same orientation as this triangle. So my 45-degree angles are here. The sides across from them are 1, and the side across from the 90-degree angle is root 2. So what I have here are two similar triangles. All of the angles are the same. So we know that these triangles are similar. So we can write proportions relating the corresponding sides. So let's do that. This side that's 2 root 2 corresponds to this side that's 1. This side that is B corresponds to 1. And A, the hypotenuse, corresponds to root 2. It's important to notice that all my values on top of the fractions came from the same triangle. So now I can use this fraction here, 2 root 2 over 1, to find B and A. So I'm going to write two separate proportions. In this one on the right, since 2 root 2 and B are both divided by 1, we can get rid of the divided by 1 and find that B is equal to 2 root 2. Which makes sense since this leg and this leg should both be the same, and they are. This one takes a little bit more work, not a lot. We'll cross multiply. A times 1 is A. And I'm going to have to multiply root 2 times 2 root 2. I can multiply things that are underneath square roots together. So I'm going to multiply this root 2 times this root 2 and get root 4. So I'm just multiplying the 2's together and keeping it underneath the radical symbol. Then I can simplify root 4. As you probably know, that's 2. Up here, this was 2 times root 4, so now I have 2 times root 2, or 2 times 2, and I find out that this hypotenuse is 4 units long. So that was a lot. So there are going to be some just simplifying radicals on the practice so we can get the hang of that. Let's try another one here. I have another 45, 45, 90 triangle. I'm going to draw the general triangle in the same orientation. They're similar triangles, so I can write my ratios of corresponding sides. And now I can use this 4 root 2 to find x and y. So I can write two proportions using the 4 root 2. So we're going to get that x is equal to 4 over root 2, because since x is over 1, we can just call it x. We don't like square roots in denominators, so we have to do what's called rationalizing. I'll type that in there. We have to rationalize this fraction. So we do that just by multiplying the top of the fraction and the bottom of the fraction by the same square root that's down there. So you can see I'm multiplying the top and the bottom by square root of 2. On the bottom, the square root of 2 times the square root of 2 cancels out those square roots, and I'm just left with the number 2. And up top, I just write 4 next to root 2. That represents 4 times root 2. And the last thing I have to do there is just simplify that 4 divided by 2 is 2. And that's my value for x. Since this is a 45, 45, 90 triangle and x and y represent the legs, you might guess that they should end up the same, and they do, because I have to go through the same process. So both x and y are 2 times root 2. So I want you to pause and try this one on your own. Start by drawing the general right triangle and then writing your 3 corresponding side fractions. So there's my right triangle. I draw it in the same orientation as the one I'm given, and then I can write my 3 fractions. You could skip writing this proportion, because since this leg is 3 root 2, we know this other leg should be 3 root 2, and so that's why y is 3 times radical 2. We'll find x using this proportion. Cross multiply 1 times x is x. We're multiplying root 2 times 3 root 2. I can multiply those two together to get root 4. And root 4 is 2. And then we just do 3 times 2 to get the hypotenuse to be 6. So I want you to try one of these and put your answers on the Google form. I'll give you a spot to tell me the answer of U, and I'll also give you a spot to tell me the answer of V. Just do the best you can, and we'll talk about these in class.